The Arctic, an enormous geographic region on the world's map. Almost 30% of the planet's oil and gas reserves may be lying under this vast, thick sheet of ice and snow. At today's rate of consumption, these reserves can sustain humanity for no fewer than 150 years. Almost half of this hibernating treasure lies within the territory of Russia. But how do we claim it? Sub-freezing temperatures, fierce, icy winds, polar night, dangerous life, and labor conditions. There is a place on the map, Tambay, on the Yamal Peninsula. What you see is real, not CGI. This is typical weather for this part of our country. Imagine temperatures below minus 31 degrees Fahrenheit together with 45-mile-per-hour winds. Despite this, the region's commercial development continues. On this program, we will take you to the coldest and most distant territories of Russia to see how people survive and work hard in conditions like these. The heroes of this film are the real conquerors of the Arctic, the people and the machines at their command. For hundreds of years, people tried to tap the riches of the Arctic. The process was slow and difficult. In modern times, we rely on machines that are built for Russia. This alliance of men and technology has opened many new opportunities. This is the Yamalo-Nenets Autonomous Region. Here, under 500-meter-thick permafrost, lie the greatest gas and oil deposits of Russia. They were discovered almost half a century ago, but only recently have we developed the technology to exploit them. One of these man-made wonders is the Arctic Gate Terminal, which opened a new page in the history of oil extraction. There is only one way to the Arctic Gate oil terminal. That means is by helicopter. The Mi-8 model is the most reliable. Day after day, these Mi-8s get people to work and back home. Their flights are dictated by the actual weather conditions. Today, we are in luck. The weather is good. It's cold, of course, but the sky is clear and the winds are light, so we can go. The helicopter will take us to Cape Kamini in 2 hours. The Yamal Peninsula is famous for its unique hydrocarbon deposits. There is enough oil and natural gas here for 30 years of continuous production. The climate on Yamal is typical for this region. 9 months out of 12, it is winter, with temperatures down to minus 76 degrees Fahrenheit and ferocious snowstorms. In conditions like these, indigenous residents would only travel by reindeer sleds. The epoch of reindeer sleds has passed. People now rely heavily on off-road vehicles. This is a Trekkel Arctic vehicle. Look at these wheels. They are almost as tall as I am. These are tubeless tires. The pressure inside is only 0.6 atmospheres. Getting into this one is a real challenge. You have to be flexible and preferably a mountaineer. When riding along snow-covered highways, Russian Trekkels follow the usual driving regulations. But when they are off-highway, they are almost like ships drifting in the blinding white sea that is the Russian tundra. The major problem of Yamal's deposits is transportation of its hydrocarbons to the continent. Delivery by railroads or highways is only possible in winter, but building and maintaining an oil pipeline on permafrost would be too expensive. This is why the most reliable annual route of transportation is the Northeast Passage. This is where one can truly understand how far technology has progressed to serve human needs. The severe conditions of the high north, the waters of the Gulf of Ob, the ice below me is 2 meters thick. And there, 2 years ago, Russian engineers built the Arctic Gate, a unique industrial project with outstanding parameters. There is nothing like this in any other country. All year round, this offshore oil loading terminal offloads tons of Novi port oil, which is then shipped to consumers in all parts of the world. To load oil directly onto the tankers, the Arctic Gate was constructed in the abyssal area of the Gulf of Ob. The total height of the construction is 80 meters. It's equal to a 32-story building. The terminal rests upon 12 reinforced concrete piles going as deep as 85 meters into the permafrost. This platform can be used in temperatures ranging from -50 to +30 Celsius. The terminal is connected to 2 oil pipes with a total length of 8 kilometers. They are like vessels for the blood of the earth, oil warmed up to +45 degrees Celsius.
The module is able to rotate all the way through 360 degrees. The terminal is equipped with strain gauges. If the strain of the mooring hawser reaches 100 to 110 tons in the process of loading, it triggers an emergency shutdown. This safety measure is designed to protect the tanker, terminal, people, and the very environment itself from damage.
More than 8 million tons of oil can be transported to the continent through the Arctic Gate annually. This is true black gold with its own unique parameters. Yamal's oil is recognized as a distinct benchmark, Novi Port. This benchmark belongs to the light oil category. It contains very little sulfur, which is a great advantage over major benchmarks such as foreign Brent or our own Ural. In winter, the waters of the Gulf of Ob become icebound, which makes it impossible for tankers to reach the terminal for loading. Fortunately, we have 2 mighty icebreakers to clear the way for the petroleum to keep flowing. We're now boarding the general-purpose rescue vessel, Baltica, which is also an icebreaker. In winter, they use an exotic way of boarding in a special cradle, which I'm riding in now. You can also board the ship by gangway, but this is only possible when the weather is warmer. A winter shift on an icebreaker lasts 4 months. All 26 crew members live as a family, and each one of them is an expert in multiple fields, from cook to surgeon. The Baltica is not a usual icebreaker. She is the world's first oblique icebreaker with an asymmetrical hull.
She is called oblique because she has an asymmetric hull, which means one side is oblique and the other side is straight. The oblique side is better for icebreaking, while the straight side is used when we need to clean up an oil spill. We turn the vessel straight side to the spill. There's a special hatch there. It opens, the oil spill enters there, and we suck it up back into the tanker.
There haven't been any emergencies yet, so the icebreaker's unique capabilities have only been tested in drills. The captain of this Arctic Titan is Mikhail Silyanov. He has served on this icebreaker for 4 years since her very launch, so he knows every single part of her. The vessel is capable of breaking ice with her bow, stern, or even her side. At first glance, it looks simple, almost like playing a video game with joysticks, but in fact, this is an enormous heavyweight colossus.
This vessel is designed in a specific way. It is equipped with 3 azimuth thrusters. The propulsive screw can rotate directionally, as you can see, 360 degrees. This is how it rotates. We have 3 of them, 1 on the bow and 2 on the stern.
Well, let's turn one of them.
You mean?
Let's direct them somewhere. Suppose we go forward.
You put your hands there if you want to turn the ship. Well, you have to handle many things at the same time. This is generally quite difficult.
You can feel the cold breath of the Arctic Ocean thousands of kilometers away from Yamal. St. Petersburg became the cradle of the new generation of Arctic machines. Inside the belly of the Baltic shipyard, the mightiest fleet of nuclear-powered icebreakers in the world is being constructed. Only a few years remain until 3 new nuclear-powered icebreakers sail the Northeast Passage: the Ural, the Sibir, and of course, a flagship with the legendary name, Arctica.
Her ice-breaking capability is almost 3 meters. To be more precise, the engineering design reads 2.8 meters. No other icebreaker can traverse through such thick ice. The ship owes this ability to the extreme thickness of its outer hull, an average of 40 millimeters at the ice belt. She is the most powerful icebreaker in the world.
Is this fiction? No, this colossus is very real. The deck area is equal to that of a football field. The 2 mighty nuclear reactors can produce light and heat for an average-sized city like Arkhangelsk. Arctica is a universal icebreaker. In the open sea, her draft, or the distance between the waterline and the keel, is 10.5 meters. But if she has to escort vessels through shallow waters, for instance the mouths of Siberian rivers, the ballast water is dropped, and the icebreaker's draft drops by 2 meters.
Considering that icebreakers are deployed in sub-freezing temperatures in the Arctic, the steel for the hull was smelted in an electric furnace with a capacity of 120 tons. After that, the steel was forged under an immense press with the power of 12,000 tons of force. In addition, the steel had to meet additional requirements for its mechanical properties.
At low temperatures, cold-resistant steels have higher plasticity. Our experts have learned to change the molecular structure of metal by doping. This is the process of adding chrome, nickel, or manganese. Steel with these enhanced properties is smelted in the electric furnaces of the Izhorskaya industrial site in St. Petersburg at the temperature of 1500 degrees Celsius. The propulsive screws of the icebreaker Arctica are made of this steel. The steel was poured into great castings with a total weight of 350 tons. This is the weight of 7 military tanks.
The vessel has 3 propulsive screws, and each of these screws has 4 blades. This is a custom-designed component made of stainless steel, the composition of which is protected by a special patent. Because the vessel will be deployed in Arctic climatic conditions, the requirements for its casting are the highest that have ever been required.
The shafts for the engine unit of the icebreaker Arctica were made by experts of the OMZ Special Steels Company. No one in Russia has made anything like this before. The weight of each shaft is 68 tons, their diameters are each close to 1 meter, and they are more than 16 meters long. Despite their size, the processing accuracy is down to microns. This super construction has to rotate at the speed of 2 turns per second without any vibration, and there are 3 of these shafts on the icebreaker. They are the steel spine of Arctica, transferring the power of the nuclear reactors to the propulsive screws. This unique order took half a year to complete, and it met all the specific Arctic requirements.
First of all, we are talking about reliability. If the icebreaker's engine unit falters for any reason, it will lose propulsion, which jeopardizes the vessel that the icebreaker is escorting through the ice field. We understand and accept the requirements that the engineers ask from us, and we never fail to meet the quality expectations that our contractor demands.
The renewal of the Russian icebreaker fleet will have been completed by 2020, and the new nuclear vessels will ensure the fastest delivery route between Europe and Asia. It is hard to believe, but the route between 2 cities on opposite sides of the planet, Yokohama in Japan and Rotterdam in the Netherlands, will become 4,000 miles shorter and 2 weeks faster.
We can draw parallels with the Suez Canal, which amounts for almost 5% of Egypt's gross domestic product. The Northeast Passage provides the same for us. It opens up a historical opportunity for Russian foreign companies to deliver goods faster than ever before. Time is money, so speed always saves expenses.
Let's go back to the polar circle, to the Yamal Peninsula. It's warmer now. The weather is what they call normal, minus 32 Celsius. Despite the biting cold, people keep on doing what they came here for, which is to extract natural resources. This tower in the middle of snow-covered tundra is the most important project of the Uralmash Oil and Gas Equipment Holding Company. This is the starting point of the long process of hydrocarbons development. The Arctica boring rig is protected from harsh conditions of the environment by special measures. They allow for continuous boring at temperatures as low as minus 60 degrees Celsius and winds as strong as 55 miles per hour. This range is quite sufficient for the Arctic and subarctic climates. The purpose of the boring operations is to reach natural gas-bearing formations lying as deep as 2,800 meters below the surface of the Earth. The deepest progress so far has been 2,350 meters. The deadly union of strong winds and freezing cold previously made boring north of the popular circle impossible. People used to wait for weeks to start working. With the boring rig Arctica, weather dependence has become a thing of the past.
As of now, this boring rig has 0 hours of weather downtime. That was the major requirement for installing this wind protection, all in order to protect people from strong winds, snowstorms, and low temperatures, and keep the work going.
All working sites, hubs, accessories, and facilities of the Arctica boring rig are protected by a reliable thermal cover, the maximum height of which is 60 meters. This boring rig is designed as a modern, ergonomic alternative to obsolete rigs. It doesn't affect the environment, and it is capable of translocation to another drilling site in a short amount of time. This process used to take almost a week. Now we only need a day. The complex is managed by a digital automated control system, which is connected to the central office via satellite. The drilling is accurate to within meters, which ensures high field potential.
As for the borehole we are drilling at the moment, the horizontal reach of the productive formation is going to be 1,000 meters. This is going to be a horizontal formation, meaning that it runs parallel to the surface of the Earth.
Along with oil, Yamal also produces natural gas. In the past, they used to simply burn it. Now, it is used to facilitate oil pumping from several kilometers deep. The deeper the oil lies, the more effort is required to extract it. Behold, the latest piece of complex Russian equipment, the gas treatment facility. What is this doing? It dehydrates the gas, decontaminates it, pressurizes, and most importantly, pumps the gas back into the formation. The unit is pretty large and very noisy. Some of its parts weigh more than 60 tons. This unit helps preserve the Arctic ecosystem. The associated gas is not merely preserved. This gas is used as fuel for gas turbine electric power stations. In the past, the formation was cracked open by drillers, its oil was extracted, and the gas was burned or released into the atmosphere. Because of this, the pressure inside the formation would drop rapidly, and oil extraction rates would drop with it. But if you capture the associated gas, pressurize it, and pump it back into the formation, pressures will drop at a lower rate, and the period of oil extraction will be longer. This means we are exploiting the Arctic treasure much more efficiently. In the future, at the end of an extraction cycle, the gas will be delivered directly to consumers through pipes. This low-waste technology will not add to pollution.
This piece of technology, the gas compressing unit Ladoga, combines the most recent engineering ideas. It is fully autonomous. This unit is controlled from an operating room in a facility or administration building. People need only inspect it and maintain it.
These unique gas turbines are produced by the St. Petersburg-based REP Holding Company. It has produced more than 60 of these turbines.
This is a modern stationary gas turbine with the power of 32 megawatts, which meets environmental requirements and has high energy conversion efficiency. This turbine is unrivaled in Russia in terms of emission levels, which means it emits very small amounts of noxious substances.
The life cycle of the Ladoga unit is over 200,000 hours, more than 20 years of continuous performance in permafrost conditions. We can be certain that for the following decades, gas and oil drillers will be extracting fantastic amounts of hydrocarbons, despite the frozen and windy air of Yamal.
The fields lying close to the surface are almost depleted, so we have to constantly search for new reservoirs. As of today, the major development direction of Gazprom Neft is north, to the Yamal Peninsula.
Another Russian region with extreme conditions of life and labor is the Yubilennaya diamond deposit in the Aikal settlement, located in the Republic of Sakha, also known as Yakutia. Under hundreds of meters of permafrost lies one of the largest diamond treasuries. Millions of carats worth fighting for. Almost all of Russia's and 1/4 of the world's gem quality and industrial diamonds are extracted here. People live and work in a constant struggle with the weather. The harsh nature of Yakutia does not give up its reaches easily. Using a special explosion-proof camera, we will see how diamond ores are recovered right at the explosion's epicenter.
The permafrost here is about 100 meters deep. We set off a 400,000 cubic meter explosion, burning 330 tons of explosive materials.
To reach the diamond fields, giant quarries have to be dug. The Yubileni quarry is an immense funnel with a diameter exceeding 2 kilometers that goes over 400 meters deep, following a diamond-rich kimberlite pipe. The Yubileni quarry is where Russia's largest diamond was found. Here it is, the world's fourth in size. It is stored in the state repository. Even though this diamond is not gem quality, it is nevertheless priceless, because it is history itself. It has been given the nickname 3/8, because it weighs almost exactly 888 carats. Diamond extraction in Yakutia is complicated not only by weather, but also geological conditions. Precious stones are encased in massive rocks. Mighty open-pit excavators literally gnaw at them with their metal teeth. The volume of their buckets is 15 cubic meters, the size of a small car.
These are KG-15M excavators, produced at the IZ Cartex. They use cold-resistant steels and special grease, all of which allows these machines to work at extremely low temperatures, plus the heaters. They install heaters in the main gearbox, which also make these machines viable for our challenging weather conditions.
The weight of a Cartex excavator is over 700 tons, as much as a passenger train. Despite the size, they can move without towing. They are quite slow, 300 meters per hour, but still, it's enough to consider them the mightiest robots on planet Earth. When you are inside of the cabin, you are amazed by how easy the communication between man and machine actually is. It looks pretty much like conducting an orchestra.
This is another computer. We are connected to machines. I mean, I do not have to dial an operator's number to call an operator. I do not need that. This makes work easier and working efficiency higher, as nothing distracts you.
Every quarry excavator has to meet extremely high requirements set by contractors from the Arctic and from beyond the polar circle.
For 5 years, our potential contractors have been sending us engineering projects with maximum temperature requirements of -50 Celsius instead of -40. In addition, when we gather for meetings, they inquire if our company is able to produce machines for temperatures as low as -60, in some cases even -70 degrees.
The most important pieces of the excavator, such as the rotating engine, are made of hardened steel with a high level of plasticity. The rollers of the engine rotate upon bushings made of polymers, which means that there is no need for grease. This is especially important at low temperatures. Men and machines also work together underground at the adjacent mine, Aikal. For 10 years, diamonds were extracted from an open pit. Then, workers had to go deep underground to follow a kimberlite pipe that contained precious stones. Robots aid people in the most dangerous areas. For example, they help build the tunnel shafts of the mine. With them, construction is faster and more accurate. The program is written by an operator, and the machine complies, performing tasks at the edge of a 10-meter deep precipice.
You have a USB flash drive. It contains a boring pattern. You plug it into a computer, input the pattern here, and then transmit it to the control panel. Then go to the control panel, press start, and the boring commences.
When the shafts are bored out, explosives are detonated in them, and the kimberlite ore collapses to the lower level of the mine, where it's collected by a grader. This mobile robot is controlled by an operator who follows it at a safe distance. Machines can perform tasks without their masters behind them, but this would require us to robotize the whole underground complex. In 5 years, artificial intelligence will probably dwell underground.
We know that the deposit is large enough to last for many decades. Even the mid-range forecast extends as far as well into the 2050s.
Oil, gas, and diamonds are but a small part of the riches hidden under the ice shell of the Arctic. Humanity just recently started developing these resources. Just imagine, the value of explored deposits is almost $2 trillion, and much more remains unexplored. According to preliminary estimates, there are $30 trillion worth of minerals and fossil fuels in the Russian Arctic. The prospects are colossal, and this potential can only be unlocked by the union of man and machine.
This is enough to allow our successors to keep balancing and developing the economy of the Russian Federation. This is not only a project for today, because what we do today is for the sake of future generations.
Russia has always been the world's coldest country, which means we have to remain on the edge of technology for developing seemingly inaccessible territories. We have to build machines and design accessories that will facilitate labor in this frozen part of the world, as in the 21st century, life beyond the polar circle is only beginning.